So good afternoon, everyone. Thank you for joining us for this second E-SWAN sustainability webinar. So today we are welcoming Dr. Sylvain Bontemps. So Sylvain is a senior research staff at the Laboratory of Astrophysics in Bordeaux, and he is also a director of research at CNRS. After a PhD on outflows from low-mass protostars, he has been working at the Stockholm Observatory before moving to Bordeaux in 1998. He has been part of the science team of the ESA Herschel mission on nearby molecular clouds, and since 2013 he works on exploiting ALMA and IRAM telescopes at millimeter wavelengths to reveal the earliest phase of the formation of high-mass stars. So he works essentially on the origin of low and high mass stars in the galactic interstellar medium, as well as on the origin of dense structures at the origin of stars. So since 2021, he is deputy director of the Laboratory of Astrophysics in Bordeaux. And last year, he has coordinated a working group on drawing a plan and directions to improve the sustainability of the astronomy and astrophysics research activities of the French community as part of our INSU CNRS 5-year prospective exercise for 2025-2030. So as you can see, he is not working on our field. So that's good to have someone talking from another part of astronomy, but we are very happy to have him today. If you have questions at the end of the webinar, please, you have a button at the bottom center called Q&A, and so you can ask your question in the chat. And so I'm going to let Sylvain start now. Thank you very much.
Thank you, Aurélie. So thank you for this opportunity to make this a small presentation about, as Aurélie said, what we have been doing to prepare this perspective in France on astronomy, where we were asked this year. It's a 5-year perspective, so it's for 2025 to 2030. We were asked to question to which extent and what are the plans to reduce our environmental impact of our activities. And so I'm going to show you what we have been doing and a bit of the result and reaction of people, and to help you perhaps in your own field to approach this difficult issue. I want to say that it was a part of a work done with several persons, which are here. The group is indicated here. So all French, because that's a French exercise. And that was a very interesting, I would say, exercise to lead this group. Very interesting in the sense that it's a difficult issue, but also very interesting because it touched very much the sense of what we do in science, and it has something to do with impact of the society. And generally speaking, it's a small micro exercise of what's happening in the whole society, I think. So I will explain you a bit the context of this, what we have been doing in this working group, the methodology we used, a bit of the result and diagnosis we could make out of this exercise, some idea of recommendation we go for, because we are not quite finished, and the final document will be delivered next year. And a bit of first result or impact on the French community so far. So very few, but it's quite interesting to see that things are still moving after such exercise. So if I manage to, oh, sorry. Yes, okay, it works like that. So I'm not going to convince you that climate change is something very urgent and that it is now. So this plot is, probably you know it, it's about to show that people born right now will be directly and extremely impacted during their life of the warming, which is in action right now, whatever the intensity of it. And second, so it's clearly urgent. We can't say it's going to be something we treat in 5 or 10 years now. It's very urgent to act now. That's clearly a very important thing to realize. We are all scientists of complex systems, so we know very well what means nonlinear behavior, and clearly we know that playing with the climate in such a complex interconnected matters and issues. Here I make an example about water problem in agriculture and the fact that the risk associated with it, but it can be on lots of matter. So it means the risk associated are difficult to measure and can be really suddenly making some twists which are difficult to predict and potentially extremely impacting. So it's another plot for that, and it's just remind people that global warming go sometimes to significantly increase of mortality. It's not only biodiversity and small animals. It's all about our way to live and substantial difficulties like international or local conflict, which can happen quite fast. And at the same time, the complexity of these processes are far to be completely understood. When we take example of Arctic region, where the loop and the side effect of the global warming are far to be completely understood. Concerning what we have in front of us in France at least, and that was the starting point of our context for this working group, is what's happening in France, generally speaking. It's called the low carbon strategy of the French government. So basically it means that that's a curve of the global impact of the state. So starting from 1990, and now we are more somewhere here. And the plan of the state to go to a neutral carbon situation in 2050, meaning that we need to decrease by something like 30 to 40% in 2030, hoping to have an increase also of absorption to have neutrality of the emission, which are probably very difficult to arrive to zero concerning carbon. So generally speaking, what we have to have in mind is that the correct trajectory is something around 6 or 7% decrease of carbon footprint per year. So it means also that we in a framework that as a public state worker, we have to follow some decrease and to think about how to do it in a proper way. So generally speaking, we all know that it's a difficult, it's really a challenge to do so, especially that when we are astronomers, for instance, we easily say we represent more or less nothing about this global footprint, and we can always argue that the military are going to do much more, that the transportation is also what we should take care of first, and building sector and so on. But actually, when you get on the projection of, here it's a projection of the state again, all sector, more or less all sectors have to decrease. Here, that's what the French government foreseen already some years ago, which is basically industrial sector minus 35% in 2030, energy minus 33, minus 30 for the transportation. Agriculture is the less asked for. It's minus 20, but generally speaking, nobody can say we should not reduce. It's all about to reduce everywhere where it's possible. So all ideas that it's about to the others to do something is a way to avoid the real problematic we have in front of us. So in this context, to go down in scale, we arrive to the commitment of research agencies in France, which have signed a number of commitments. Actually, it's not very restrictive what's about to be asked. I'm sorry, it's in French, but it's about to commit themselves to try to improve, to support good direction, to drive transformation, to be exemplary, to share what has been done at all scale, and so on. There is no numbers there, but it's the commitment of these agencies. The CNRS, for instance, is part of it. The CNES also, you probably know, was in the beginning of this year, so it's progressing in this direction. We now expect to have numbers and to have clear guidelines to progress, I would say. So also what is quite important to have in mind as a public researcher is that we probably have a code of ethics we have to consider. So the CNRS, for instance, published a report 2 years ago about the fact that not accounting properly on the environmental impact from on our research activity right now is an ethical issue, actually. It means it's not ethical to not trying to decrease or to do what's proper to reduce our impact, since we know that it will have an impact on the society, on the population. And generally speaking, as a public worker, clearly we have to remember that we work for the general interest of the population of the state. And if we are convinced that the general interest implies that we change strongly our practices, it's important to keep that in mind. So it's an individual also pressure, I would say. So we were asked to think more about how to do that for astronomy in France as part of what we call the prospective of the part of the CNRS, which is for the astrophysics, which is called INSU, Institut National des Sciences de l'Univers. And we do that every 5 years. So that's the main page of the one of 2019. And now we are in the one of 2024 for the exercise of 2025 to 2030. So as part of this work, which is typically lasting for 1 year of work of several working groups, 9 working groups, one of them was dedicated to the transition for decreasing our carbon footprint and, generally speaking, the environmental impact of our activities. So we built up a small group to work on that during 1 year. So the people are indicated here. And the goal were to question where we are instead of action already in place. How to follow up our carbon print. It means measure correctly things, which is not that easy. Propose a strategic plan and recommendation to reduce our impact. And all that with verifying that we have an agreed commitment of all actors, mainly all the staff of our laboratories. And also think about action to anticipate the difficulties and to strengthen our resiliency of our activities in a world which is most probably going to change quite fast and not necessarily in a good direction or in an easier direction. So it's quite important to prepare such a situation, even if I have to say we could not go much in that direction because it's difficult. So our methodology was in our calendar. I mean, the time scale, what we have done during the last year was to start to go to the direction of the laboratories working on astrophysics in France. So it's something like 20 laboratories, 16 could be interviewed. And so we wanted to know how was the direction of laboratories were handling this problematic and what they want to do and so on. I will show you a bit of that. We made some other interviews of all the actors of the astrophysics in France, especially representative at the state level, because where the decisions are taken, it's quite interesting to understand what is possible or not possible, actually, most of the time. We went also directly to the staff by 2 community surveys, individual and collective in labs. We had to decide how to treat all this information and how to have a plan to prepare some recommendations. So we had a small brainstorming workshop in Montpellier in April for that. We make a first short report in June and distribute it to the French community in July to have some feedback. We prepare a list of questions to be debated at the colloquium, which is always, we have always a colloquium every 5 years to discuss all these prospective issues. So this time it was in Autran, in Vercors, in last September, 23 to 27. So we promoted some debate again on this question during this colloquium. And now we are in the level of, we just received the synthesis of these returns from this debate of Autran in December. It just arrived a few days ago. And we will finalize all the recommendations and the reports in February 2025. So that gives you all what we play with in France when we make this perspective and when it's about to question this transition issue. So what we get, it's not going to surprise you, but that's the numbers we extracted in the case of the French impact of the astronomy in France, but it's probably very similar in other countries. Generally speaking, it's important to realize that all what I show here is all in progress in the sense that to estimate the total greenhouse gas emission, it's not that easy, or everybody knows that. All what we have done so far is based on what's called carbon intensity. It means the conversion of money to carbon emission, generally speaking. So that has to be much improved, but that's give already quite a good order of magnitude of what's happening. So generally speaking, we arrive that if you count on everything, it means our travel to work, what's happening in the laboratories, warming the buildings, mission, flights, all what is bought and purchased in laboratories, but also all the participation of the French community in the international observational facilities and ground and space. We arrive to close to 60 tons of CO2, equivalent CO2 per year per astronomer. So it's not all the stuff. Here it's counted by astronomer with something like a bit more than 600 astronomers. I think it's even more, closer to 700 actually. We arrive to a total of 35 kilotons per year for all our activity. But what is interesting is that it is cut in 3 pieces. 1/3 is inside the laboratories and 2/3 are ground and space mission, generally speaking. It means we probably have between 60 and 70% and even more, because in the laboratory, some of the purchases are dedicated to observational facilities are related to our telescopes and space mission, generally speaking. At the time of this evaluation, some years ago, because it's based on Knott-Zedler 2022, which is a Nature Astronomy paper, and the fraction was more or less the same between space and ground observatory, what is obtained this way. Sorry, if I continue. So that's so this carbon intensity is clearly something which is important to follow up, and to, generally speaking, if we make some eco-consumption of our facilities, we should decrease this in carbon intensities. That's the idea of decarbonization, mostly based on changing the material, but also, of course, the energy which is required for all that. We know that for the observatory, like at ESO, more and more of the big instruments consume a lot of electricity, so it's directly related to the energetic mix of the country where it's happening. So any improvement of that will decrease this carbon intensity, making that we could keep some very efficient observatories with less carbon footprint. But that was the situation. That's some extrapolation made in the new paper of Jürgen Knott-Zedler, where they were wondering to which extent we have already a trajectory to reduce, which happened to not really to be the case. The reducing the carbon footprint of our observational facilities, space and ground. So space here is in blue and ground is in green. So actually here, the difference is large. I don't remember why the ground is much smaller than the space here. I'm sorry. Okay. When we have done that for more specifically for the French participation of a number of instruments, and we see that in 2024, between 2019 and 2024, we had a tendency to decrease, but what is already the French community is already committed in a number of large instruments like SKA, CTA, and the ELT. And just all that already makes that most probably we will increase the carbon footprint of our activity to make research due to there's a big instrument arriving on the sky, except if we manage to improve the eco-consumption and the energetic mix used for that instrument. And that's already the case for SKA and ELT, which work to reduce their carbon footprint by improving the electricity decarbonation. But so right now the trajectory does not seem to be good enough. So that's a bit what we immediately arrive when we evaluate where we are. That generally speaking, we have the laboratories which make 1/3 of our footprint, 2/3 is observatories, generally speaking, and that the observatories, generally speaking, are not right now on the right track to decrease their footprints. It would even tend more to, if we don't do anything, to increase. So we went like that to the directors of laboratories to ask them a number of questions at the interview. So they are there. We tried to push them to think. So it was interviews, but a lot also discussion, meaning that it's quite useful to listen to people and to listen to people in charge, and also to push them to think about what has to be done. So it was really exchanges, and it was often very, very long. We had often more than 2 hours discussion with the direction of the laboratories. And that was the question we asked to them. So first, it was about to know if they have already evaluated their carbon footprint in their laboratories, and if not, why. What are their present action to reduce? Which sort of issues they have to get in action, and what they expect from CNRS or universities to help them. Is there some breaks or difficulties they had? And generally speaking, after the more tricky question was about to ask them what they would think of being more selective among the supported observational facilities and instrument developments of the community, because generally speaking, the laboratories depend quite a lot on budget coming from developing all these instruments, and that's a usual way to progress in science, to have new instruments and so on. So it's really touching the heart of our activity. So it's really touchy. So we asked after some of the questions, but that was really the critical question is about being selective, which is often understood as we want to stop observation facilities, which is of course not the sense of the questioning, but people get rapidly afraid when it's about to question that. So generally speaking, we try to measure the direction of laboratories were involved in such a process. I would say that, to summarize, we were between okay but worried to fully convinced but late in deployment of actions, I would say. So I'm sorry, it's this histogram is in French, but that's basically a summary of what we had. After concerning the important question I made about making stronger choice about observing facilities, they were really going in the direction of most of them. It's of the order of 75% of the direction of laboratories, so over 16 laboratories. It's not a huge statistics. That they were okay to make stronger choice with environmental constraints, and to go in the direction of using budget more to exploit data instead. But they also asked a lot to have clear guidance of the CNRS, of the government, and of university to be able to put in action what is asked for. We went also to community survey. It means anonymous survey, which were proposed to all the staff in France. So what was quite interesting is that such a survey was already done in 2019 in another context. So we tried to reproduce the same one, just adding few questions in addition to make a derivative in between this along these 5 years. So we managed to get several hundred of answers. Again, I'm sorry, it's in French, with the researcher in orange, the postdocs and CDD in green, PhD students in blue, and technical staff in red and a bit reddish color here. So it's a lot of researchers which answered, but we could in a way make this nice comparison, and even if it's not completely the total number of staff which answered, it's a significant number. You can compare that to a number of staff in France which is close to 1,700, but for researcher it's more 700. So researcher 60%, you see 240 related to 700 persons. So it's a bit less than half, something like 40%. But on the other hand, people who did not answer don't want to participate to this process, which is a bit of pity, but which says something. So among that, we were first asking them if they feel an improvement between 2019 and now. Generally speaking, that's the histogram on the left. You see that they move from they don't think there is improvement to rather agreeing on the left. Again, it's in French, I'm sorry. So a change between 2019 and 2024, so it's an improvement. When we ask if universities, CNRS, and so on make enough for dealing with the transition, there was not much change, staying in the part where people are thinking it's not enough, clearly. So there is a feeling that our institutional agency are not playing enough role and not pushing us in a way to progress on the transition. Other question which were interesting is do we have to be exemplary for the rest of the society? Most of the answer are very strongly fully agreeing with this statement. Do the public research should have a pluriannual with numbers to reduce our emission? Again, it's quite clear. There is even a small progress between 2019 to 2024 on this question. More and more people are thinking it's really important. Other points which were quite important, because that's a tricky point again, which is about, we had this question, since 70% of the emission are from observational facilities, do you support the idea to reduce the number of such projects? So the blue is completely agree, the light blue is more or less agree, and green average, and after you get disagreeing. So it means up to average, which is on such a touchy question is already almost a yes. We arrive to 76% of the people answer, which think it has to be. And interestingly enough, if we don't make this transition or don't reduce our facilities, do you think we will be forced to do it anyway later? And there you get 10% more people who think that anyway, yes, it will happen. So to some extent, even a part of the one which do not want to do it, they think anyway it will happen. So to some extent, the right behavior is to anticipate at least. Okay, so we can conclude that this survey says that the people who are ready to answer such survey are convinced that we have to move, and they are more or less all ready to do something. I mean, at least at a significant fraction of the population. We also try to push to have debate in laboratories, in the sense that instead of answering alone on your computer, it was about to have debate in laboratories on some question and to see collectively what would be the answer. And also, what is interesting in this exercise is that we try to have the PhD student and postdoc together, the technician together, and the astronomers together to see if there were some differences, and to let people discuss more also to some extent. Because in such a debate, usually it's more the senior people who have more influence, and the young one may say more what they think of. So that's a question we asked to them. Again, it's going a bit in the same direction. Do astrophysics can play a role to fight against the climate? So it's a very open question. What would be the main rules? What are for you the main role of astrophysics for the societies? Do you think the mission of astronomers should evolve in this context, and in which direction? Again, do you think that a really significant reduce of our emission in astrophysics is necessary, even if at the price of reducing the number of observational facilities? So that's a touchy question, and so on and so on. So generally speaking, if we try to summarize what came out of this debate, is that we had varying position and fears about reducing our involvement in observational facilities. Clearly, there are fears which are logical. We touch really the heart of what we do, because observational facilities improving all the time is definitely the way to progress on the question which we really want to address. There were, on the other hand, not quite rare strong position against the idea. It means that people are ready to accept some adjustment at least, but they clearly say we should reduce first all the rest, the laboratories footprint, carbon footprint, and all the redundancies, especially international redundancies. We should improve the exploitation of existing data too. There was a fear of loss of international competitivity as a French perspective if we reduce our involvement in international projects. And on question on our role, it's clear that people feel that the fascination for astrophysics allows for efficient diffusion of strong message in society. But for that, we have to be exemplary to be listened to. And so people are ready to play this role, at least some of them, but they feel that if at the same time we don't show that we ourselves improve the situation, it will kill completely our messages. Okay, I'm going to go to some of the recommendations, or the most important one we ended up, even if that's something we still work on it. So act to reduce our impact. Generally speaking, it's very important to measure properly the impact first, and clearly there's still a lot to do to diffuse information, to promote debates for all staff. We really see that people who have been confronted to debate on this question really progress on their ability to change and to be ready to change. Reduce the emission with no impact on activities. Actually, there are lots of ways to have exactly the same scientific impact, but with a reduced carbon footprint. Obviously, the intercontinental flight can be more efficient. Favor train in Europe, it's quite obvious. Increase efficiency of mission. It means avoid very short mission, especially intercontinental. Reduce building emissions. That's also quite obvious if all the buildings we use are using less energy to be warmed up. If the clean rooms have a solar panel associated, and things in this direction is clearly very important to do. And take care, watch out, rebound on numerical application. We all know that we use more and more computational facilities, and AI is not going to improve this situation. So we have to be to control this potential increase of energy consumption in that direction. Do better with less environmental impact. Clearly, we have to go in the direction of making stronger programmatic choice for observational facilities. It does not mean to stop, but it means to master a bit more our choices. So science first. Of course, it's lots of people will answer that's already what we do. It's not always so strong, so true. So it's important to remind that. Evaluate scientific efficiency with sustainability criteria. Transfer budget to expand more the data. Avoid any duplication, which is, I already mentioned that, by increasing international collaboration. Increase the scientific return, support in priority scientific exploitation, efficient and fast, decrease the carbon-intensive production. Inflation of articles, science progress based on running to all conference, increase of number of facilities. And of course, the one I did not put is, because that's obvious, to promote as far as possible the eco-conception of any facilities and decarbonation of everywhere where it's possible, of course, but that's obvious. Okay, I'm not going to say much more, also to let you have questions. But I can say that we have some movement now. I'm not going to say it's associated necessarily to this work, but probably we helped a bit by going a bit far and having all these interviews and debates. The INSU, it means the Astrophysics CNRS part, has decided to ask all laboratories to follow a 6% decrease of carbon footprint in the laboratories, not on the observation facilities so far, but that's already a step. At the recent CNES colloquium, we heard that the moon human exploration would not have to be completely followed for science if we believe that the carbon footprint is clearly too important, or at least we should not promote that. The eco-conception of all observational facilities should be extremely favored at the ministry research level. So that's also direction which that we heard. It means the argument to support our budget for astrophysics will be more based on the idea that we are exemplary on these cases, and that we can even also demonstrate that it's possible to have very strong eco-conception. So that's also a good direction. We heard that SKO board, for instance, and heard about a French pressure, probably not only French pressure, but at least I heard this part, that it's quite important that there's 2 facilities in South Africa and Australia have a very stringent rule about decreasing their carbon footprints, especially. I'm going to stop here, so I'll let you ask me a question if you want.
Thank you very much, Sylvain. Does anyone want to ask a question? You can put your question in the Q&A chat, which is accessible from the bottom button at the bottom of your screen. Well, I can ask a question myself. I mean, I was in the group, so of course I don't have a. It's nothing very new for me, but I was wondering. We still have a difficulty in assessing this carbon footprint, and the main issue is to have the right tools to do that. Do you have any idea what would be the right path to do for having these tools? Because we have a few tools already developed by different groups or different association of scientists, but they are not really used by everybody, or they are not the same for everybody. So, and it's true that a lot of people say that it's difficult to assess this carbon footprint because the tools are not very accurate, etc. So I don't know if you have any thought about that.
I think right now we have two lines of work in this direction. The one which come from individual initiative, which are quite good and most of the time used in French laboratory, which is called Labo 1.5, which has the advantage that most of laboratories use this simple tool, which is improving over time. So there are some efforts in this direction. And if the CNRS want to do better, of course, they are welcome, and it would be good. And at the same time, but that's for laboratories, and some are perhaps the easiest part. The most difficult part is definitely the observational facilities, space and ground. And for that, at least the CNES in France is making a huge effort to do proper estimate for the space mission on which they are working, just because they are asked to show that they can handle very well eco-conception. So you need to measure first. And so they are motivated by that. They have money for that. And they deploy some effort. There are possibilities that such a tool could be applied to ground-based facility too, and also when I talk about SKAO, for instance, they are ready to pay some external expert for that, for their facility. So I'm not so much worried. It's about to say it's important to do it. It should be homogeneous at one point, of course, because intercomparison will arrive at one point. It's important that it's fair, and that we can compare to decide in a proper way concerning the science we want to get out of any facility, and also society impact. In your case with space weather, of course, the importance for society is clearly important. So it's also a very important criterion. But I'm not worried too much about that. I think the process is in place, and it's about to accelerate if it's possible, or to deploy effort like the effort in CNES, for instance. It would be good that CNRS also try to use that for other facilities.
Okay, thank you. Nobody else has question? Mary has one. I read it. In a context where resources will become more limited, have there been any discussions regarding the utility of projects? For example, should more resources be allocated to Earth observation? How to bring this at an European level and coordinate with ESA member states?
I think that such a important trade-off will clearly be happening. In our group, we were really about thinking in our cycle of influence, which is I'm convinced that's really the first step and the most important one. If everybody already in where you can act, try to find the best way to reduce and follow, that will be already a big step. After, if the urgency or urgency or the feeling that we have to be fast makes that more political decision at higher level is required, I think most of people will. I mean, some will complain, but that's fair enough, I would say. But for astrophysics, I think we have to stand on what we are asked for. It means to produce knowledge about the universe, generally speaking. And if political people who say we should decrease the importance of searching for that, we will follow. But we also have to keep in mind that all part of what we do right now, the equilibrium, the present act, has some sense also for the society to question our origins and so forth. I'm not sure I answer perfectly the question, but
that's the tricky question.
Yeah.
Okay, thank you. I think we can close the webinar. And so the next webinar will be end of January So do not hesitate to join again. And thank you for your participation, and goodbye.
Thank you. Bye-bye.